Hey, before we get into division, I want to remind you again of the textbook here and a video that's inside the textbook that also goes explains why does a negative times a negative equal a positive. So I want to remind you that it's a
Want to
short
see an
one.
amazing mathematics?
So you go ahead and
Are you
do
not
that.
impressed?
Oop, when you do that, go ahead and do that. That'd be awesome. Let's go ahead and finish this chapter. Let's see if we can get through it. On division, we have rules. So again, we're going to use the same rules for multiplication. So once we know our multiplication, then division becomes a lot easier for students to manage and understand. So thinking about division, if they're both positive, the answer is positive. If they're both negative, the answer is going to be negative. So just keep that in mind. If they're opposites, then the signs are opposite. When the signs are opposite, right? Different signs, the quotient is negative. So think about that again. Um, what do we know about division? We know A divided by B equals C if and only if A is equal to B times C, right? That's um, this inverse relationship between multiplication and division, right? We could solve kind of the missing factor approach, right? We know 12 divided by 4 equals 3 because 4 times 3 equals 12, right? So many times children solve division problems using multiplication first, and then they memorize the division part. So 12 divided by negative 3 is negative 4. Again, negative 3 times what is 12? It has to be negative 4, right? Using that missing add-in approach. Or you just know they're at different signs, negative 4. Negative 15 divided by negative 5. Since they're both negative, the answer is going to be positive. Or we say negative 5 times what equals negative 15? That has to be 3. So think about it as you see the answers. Negative 8 divided by negative 2. Positive 2 is negative 4. This is negative 7 halves or negative 3.5. 0 divided by negative 2 is what? Negative 2 times what is 0? It's 0. So we have a 0 there. We also know dividing by negative 1 gives its opposite. So A divided by negative 1 is negative A. 8 divided by negative 1 is negative 8. Negative 9 divided by negative 1 is positive 9, but because negative 1 times what equals negative 9, it has to be 9, opposite of 9. So think about that real quick as we think about this dividing by negative 1, how to think about it. Or again, it's just its opposite. What's the opposite of negative 9? Positive 9. What's the opposite of 8? Negative 8. Something to think about. Okay. Um, a rule about ordering properties now that we've kind of gone through on the operations, just some things to think about. Again, this connects to algebra. Hopefully, you're starting to see a pattern between a lot of our work connects to algebra. That's why it's so foundational to understand. If A is less than B, again, these are integers, positive or negative, right? A is less than uh, if A is less than B and B is less than C, then A is less than C. So you could see these rules here. If A is less than B, then A plus C is less than B plus C. So if I add the same amount, the inequality will still hold. Now, when we multiply by a positive, the inequality holds. Think about that. If you have A is less than B and I multiply each number by the same positive number, the inequality holds. Now, the opposite is true for negative numbers of multiplication. If A is less than B, and then we multiply by a negative number, so let's say 2 is less than 3. But if I multiply 2, let's say multiply both sides by negative 2, right? Let's just say pick a negative number, that's 2. What's going to happen is this side is going to be now greater than if I do 3 times negative 2. I'm multiplying by the same negative number, and what happens is you get negative 4, remember, is bigger than negative 6. So that happens algebraically because we're we're multiplying by a negative. The inequality sign changes. Something we're going to take with us in our algebra class. That leads us to kind of something cool. These negative exponents, which and at the beginning kind of sounds like what could they be? How can they exist? Negative exponents, what does that mean? Well, the meaning of negative exponents changes from what we learned in earlier chapters. It doesn't mean multiply. 5 to the power 4 means 5 times 5 times 5. 5 to the 0 is 1, we learned, right? So we have this definition. We've learned rules of exponents. 5 to the 5 over 5 to the cubed is 5 squared. 5 to the 5 times 5 to the 3 is 5, 8, right? We learned these rules. So with that in mind, what would 5 to the negative 2 be equal to? A lot of students think, this is wrong, a lot of students think it's negative 25. So negative exponents do not mean negative numbers. What it turns out is, take a look at this pattern here and where we get it from. Imagine doing 5 to the 3 divided by 5 to the 5. That's 5 times 5 times 5 over 5 to the 5, right? Those 3 and these 3 will divide out. So you're just left with 1 over 5 squared, or 1 over 25. That's what you get. Now, another way to think about that is saying 5 cubed over 5 to the 5, right? You have that. And from the rules of exponents, this would be 3 minus 5. So we end up with 5 to the negative 2. So you could see when the number on top has less factors than the number on the bottom, when we do the rules of exponents, we end up with a negative exponent. But we now know, we already did this problem, 5 cubed over 5 to the 5 is equal to 1 over 25. We also see that answer is 5 to the negative 2. So we then just learn that 5 to the negative 2 must be equivalent or equal to 1 over 25. They have the same value. So that leads us to our definition of negative exponents. So zoom in a little bit. A to the power of negative n is just, that's wrong too. A to the power of negative n, I got to fix that, is equal to 1 over a to the power of n, like that. That's what it is, not this. So fix that. That's the result. So 7 to the negative 3 is 1 over 7 cubed. So something to think about as we look at our negative exponents, the role of negative exponents here. I like this algebraic reasoning. It's worth taking a look and reading and then recalling, right? Reciprocals, n times 1 over n equals 1. What's 7 cubed times 1 over 7 cubed? Equals 1. That means they're reciprocals. We also know, again, that 1 over 7 cubed is 7 to the negative 3. So if we solve that problem, right, that becomes their reciprocals. So that equals 1. We also see when we do the same number over the same number, it's 3 minus 3, 7 to 0. So this goes ahead and reinforces that 7 to the power of 0 has to equal 1. They're all connected. You may need to pause and look at that, but it's definitely worth stopping and thinking about how the role of negative exponents play, how they're related, where we get them from, why it's this formula, and then connect it to some algebraic reasoning, which is not an emphasis of the class, but it's emphasis for you to know in the future so you can help your students. And then we get back to this, something the power of 0 is 1 as we look at the algebra there. I think we're going to push through and finish this video here. We end on scientific notation. We have a couple of examples here. Looking at this here, we recall from earlier chapter, we did scientific notation when the exponents were positive. Here are some examples of large and small numbers, and that's the role of scientific notation with large and small numbers, you could see. And then you could see here again, a positive exponent when it's scientific notation indicates a large number. And a negative exponent usually represents a small number between 0 and 1. So looking at this here, 0.0004, what is this number in scientific notation? It's 4 times 10 to the negative 5. You move 2, 3, 4, 5, right? You create a number between 1 and 0, and then you count how many times I move the decimal. So we have a negative number, we're looking about a small fraction. Again, remember that negative number, remember 10 to the negative 5 would be this. So you want to go back to its equivalence, right? There it is. Wait, 1, 2, 3, yeah, 100,000. So when you do that, that's why it's equivalent. So it's just another way to write very small and big numbers. But in this case, we're focusing on the small numbers because of the negative exponent. So what about these numbers? This is 12 spots, 3.5, 10 to the negative 12. 1.02 times 10 to the what? You got to count 1, 2, 3, 4, 5, 6, 7, 8. So this would be negative 8. That, again, lets you know we're going to have a very small number with the zeros and the 1.02. This one here has a lot more zeros, so this would be 10 to the power. It's going to be negative because it's a small number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, if I counted right. It's 15. I better check that answer here as we double check our example here. Let's see. We ended up with, oh, and don't forget, I have an exploration here for your negative exponents in the textbook if you want to see that. A lot more explanation too. So it's worth reading there. There's our scientific notation. Let's see if I got it. Yeah, 15. There we go. And 8 was right. And then we end with, just some more practice problems here. Where I write these as decimal notation. 3.08 times 10 to the negative 6. I would move that decimal. It has to be moved 1. So I'm end up with 0.1, 2, 3, 4, 5. Sorry for my writing. I'm using my mouse there. There we go. You have that there. And then I know this is one of the longer ones. Let's just finish this up. I apologize. We could then use scientific notation to multiply and divide numbers. You could see again from the textbook some kind of showing you some examples. What you do is you multiply the whole number parts together, multiply the tens together, the exponents, and so you end up with so it's easier to do the whole number separate, the decimals, and you end up with that. And then to convert into scientific notation, I have to move that decimal one more time. So again, you could see this becomes 2.04 times 10 to the 1, and then when I remultiply, you get 2.04 times 10 to the negative 4. So when we look at our examples here, this one here, 2.4 divided by 4.8, that's 0.5. This is 10 to the 2. 0.5 is 5 times 10 to the negative 1. And I'm putting, remember, because scientific notation needs a number between 0 and 1. There's an explanation for that further. If you want to see that again here, we can, but there. And then to finish these examples, you could see the math here done. Put it into scientific notation. 4.2 times 2 is 8.4 times 10 to the negative 2. Nothing needs to change because this number is between 1 and 10. In this case, I did it two ways. I turned this into 24 times 10 to the 4. It's not scientific notation, but it allowed me to do the math easier. 24 divided by 6 is 4. This is 10 to the 0, which is 1. But if you want to use the scientific notation, you could see 2.4 divided by 6 is 0.4. 10 to the 1. Turn that into a scientific notation and then multiply again. There's your 1, 10 to 0, so 4. That's it. Sorry for the longest video of the course, and now we've ended it here.